YouTube channel. Today we'll be discussing differentiation, but we'll focus our attention on function of a function. If you have been following this series, we've been able to iron out some issues on different topics in differentiation. We've been able to iron out the general rule, we've been able to iron out the product rule, the quotient rule, and now we'll be dealing with function of a function. You can check our video on this YouTube channel to brush up on all the part of differentiation I have mentioned earlier. As you journey through this video, you will understand the differences between function of a function and other part of differentiation that we've been treating so far. As you can see on the screen, if y is a function of x, then dy dx equal dy du multiplied by du dx. Dy dx equal dy du multiplied by du dx. By implication, if you remove this du, if this du cancel out, you will still be left with what dy dx. What do I mean? Let me quickly do that so that you can understand what I'm trying to explain. So if you, for example, I'm just using it as an explanation. If you decide to cancel out this du, if this du and du cancel out, you see you'll be left with only dy dx. That's why we are making use of this. So if you say dy dx for function of a function is dy du multiplied by du dx, because this du and du will cancel out, you still be left with what? Dy dx. That is how this formula comes about. So let's get the usage of this formula with this question that we have here. We have to differentiate. Number one, y equals 3x minus 1 raised to power 9. Second one, y equals 3 cos 5x squared, open bracket, 5x squared plus 2 close the bracket. So let's see how we can iron out that. So let's say solution 1. So this is the question. Now, first thing first, you need to understand that you are dealing with function of a function, because normally in differentiation you can differentiate only what you have here. This 3x minus 1, you can differentiate it. Now, this is another function raised to power 9. So don't forget, when we are explaining, we say if y is a function of x, then dy dx equals dy du multiplied by du dx. So let's see how we can. Now let's deal with this. So let's say let u equals what we have here, 3x minus 1. By implication, it means we are representing what we have here, this 3x minus 1, to be u. By implication, if that is the case, that means our y since we say we are representing that to be our u, that means all what we have here is now u. That's the meaning. If all you have here, we say let it be u, that means our 3x minus 1 is u. So our y now will be u raised to power 9, because we say let all this one that we have here, let it be u. That means our 3x raised to power 3x minus 1 will now be u. So our y will now be what? U raised to power 9. Awesome. So with that, we know our u now, we know our y. So let's bring our formula. It's going to help us, to guide us on what to do. Beautiful. So this is our formula. What do we need to insert in this dy dx? We need dy du. Where can we get dy du from here? This is, if if you are differentiating this dy du, so you can get dy du from here. So since our y is this, so dy du is just normal differentiation. Let's differentiate what we have here. As usual, you bring your power back. You bring your power what? Back. The power here now is 9. Then you bring what you have here. Then you minus 1 from the power. It is as easy as that. So that's the normal differentiation. That's how we get our dy du. So now that you are subtracting 1 from the power, 9 minus 1 will give you what? 8. So that's our dy. So we've gotten our dy du. This is it. Dy du give us 9 u raised to power 8. It is as simple as that. Now the next thing is to get our du dx. We can only get du dx from here because this is u and x. Let's get our du dx from here. Now this is our u. We can get our du dx from here. So let's quickly differentiate that. Normal differentiation. Beautiful. Now let's differentiate our du dx. Now looking at this, as usual, the same method. You bring what you have at the power here back. What do you have this time around? 1. Anything raised to power 1 is that thing. So because it's 1 here, that's why it is invisible. So if you bring 1 back here, you still have your 1 here. There's no point, right? Or okay, let's write it for record purpose because there's no point. You have 1 at the power here, you bring it back here. So this is the 1. So you bring your 3x that you have because the power is 1. 1 minus 1 will give you 0. Just for record purpose, let me bring it. So the power is 1. There's no point writing it, but I just need to write so that you can get the explanation. The power is 1. It's back here. This is it. We have our 3x raised to power 1 here. So you minus 1 from the power as usual. So you say 3 times 1 that you have here. 3 times 1 is 3. So 3 times 1 is 3. 1 minus 1 is 0. 1 minus 1 is what? 0. So it is. I'm just taking my time to explain this because there is no point. And anything raised to power 0 is 1. So x raised to power 0 is 1. 1 times 3 will give us 3. So this has gone. So our du dx is this. So we've been able to get our dy du and our du dx. So let's input them here. Awesome. So what's our dy du? We've been able to get that. So what's our dy? Okay, this is it. Dy du. Then u raised to power 8. And what's our du? What's our du dx? Our du dx is here. Du dx is here, which is 3. Awesome. So our dy dx is 9u raised to power 8 times 3. So if we say 3 times 9 is going to give us 27. 3 times 9 will give us 27. So we are left with 27 here. 27u 8. Awesome. But don't forget that our u is something. So let's impute the value of our u back. This is our u. We need to recall that our u is this. So let's impute this value of u back here. That's why it's called function of a function. So anyway you see u, you put 3x minus 1 in there. Beautiful. So this is our answer. So our dy dx is now 27 into 3x minus 1 close all this to power 8. That's why it's called function of a function. So let's quickly dive into the second question. Solution number 2. Beautiful. So this is our question. We'll go through the same process again. So this is a function, this is another function. When you normally you can differentiate this one separately, you can differentiate this one separately. So that's why it's called function of a function. Okay, let's say let u equals what we have here, 5x squared plus 2. Beautiful. Awesome. So let u equals 5x squared plus 2. Now by implication, if u is now this, that means all you have here has turned to u. That's the meaning. That is what it means. That means all what you have here is now u. That's the meaning. 3 cos u. That's what you are going to have. Beautiful. So if all you have here has been represented to be u, that means all you have here is u. You now have your y will now be 3 cos u, because we've said this one will be our u. Beautiful. So with this, let's bring out our formula so that it will guide us on what to do. Let's get our formula. Beautiful. Awesome. So this is our formula now. This will guide us. Now dy dx. So what we need now is our dy du. We can only get dy du from here. We can get dy du from here. Awesome. So let's see. Now we are differentiating this so that we can get our dy du. But before then, let's separate what we have here so that we can now make our job easier. Now, so let's get our dy du. this dy du. Naturally, our 3 is a constant that will stand here. Now, if you recollect, in our standard derivative, you can check our video. We explain that cos ax is still the same thing as if you differentiate cos ax, it will give us minus a sin ax. That's the meaning. That if we differentiate cos ax, it will give us minus a sin ax. Differentiating it in our standard derivative, we explain that in our product rule. You can check out that video. In the same vein, if you differentiate cos u, it will give you minus sin u. That's the meaning. If you differentiate cos u, it will give you what? Minus sin u. It will give you minus sin u. That's the meaning. So your dy dx now, your dy du will now be bringing out, multiplying these two. That means this 3 can now come in here. Awesome. So that means we now have minus 3 sin u. So our dy du is now minus 3 sin u. Awesome. So we've been able to get our dy du. So we are left with what? Du dx. So let's get our du dx. We can only get our du dx from u. Only get our du dx from u. Beautiful. So let's differentiate. So it's very key we understand the basics. You can check out the general rule on this topic that has been treated on this YouTube channel. It will go a long way to guide you. Now, let's differentiate this du dx. You can only get du dx from here. This is u and this is x. Now, as usual, let's do our differentiation. Our power will come back here. Our power, which is 2 this time around, will come back. Then we have our 5s squared. Then we minus 1 from the power. Minus 1 from the power. We have explained over and over again. If you are differentiating a constant, this is a constant. This 2 is a constant. If you are differentiating a constant is ordinary number. It will give you 0. If you are differentiating a constant, it will give you what? 0. So now that 0 has gone, 2 minus 1 will give you 1. 2 minus 1 will give you 1. Then 2 times 5 here will give you what? 2 times 5 will give you 10. So you are 10 raised to the power 1. The power, once it's 1, there is no point. You can do away with it. So you have 10x. Beautiful. So we've been able to get our du dx as well. So let's impute our dy du and du dx. What's our dy du? Let's check. Our dy du is minus 3 sin u minus 3 sin u. That's our dy du. Our dy du is what? Minus 3 sin u minus 3 sin u. Then our du dx is 10x. Our du dx is what? Is 10x. As you can see here, our du dx is 10x. So we're almost done. So all we just need to do now is to multiply this and this together. So if you are multiplying this and this together, you'll be left with what? Say minus 3 times 10 will give us what? Minus 30. But we have x here, so it will be what? Minus 30x. That will be playing with here. left with what? Minus 30x. That means this has gone, we've been able to multiply it together. Minus 30x sine u minus 30x sine u. So, but recall that u has a value. U has a value. This is the value of u. Because we're actually dealing with the y dx. You need to recall that u has a value. You need to recall that u is what we have here. So we insert 5x squared plus 2. We insert 5x plus 2 into the value of our u that we have here. That means our u, which is 5x squared plus 2, has been inserted here. So our dy dx will now be minus 30x sine 5x squared plus 2. So that's our final answer. You can always pause, rewind this video for better clarification and understanding. Kindly drop a comment with us here if you have any question or issue in any of our videos. We will reply you as soon as we can. Help us like this video and subscribe to this YouTube channel, My Simple Maths. And don't forget to press the notification bell so that you can always receive notification from us whenever we post a new video. Thank you.